Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. My name is Nur Eradaina binti Muhammad Rosti. My number matric is A220309. Today I'm gonna discuss our report business statistic from data set D. Next is introduction. Statistics serve a critical role in unveiling the complexity of data through collection, analysis, interpretation, presentation, and organization. The two primary types of statistical analysis, which is descriptive and inferential, each contribute distinct insight. Descriptive statistics, encompassing measure of central tendency and variation, is instrumental in summarizing and organizing dataset, offering a snapshot of a key characteristic. Meanwhile, inferential statistics extend the scope by enabling prediction and generalization about population based on sample data, facilitating informed decision making and policy development. The purpose of this study is to determine what data and variables are needed. Other than that, use the appropriate table to describe and explain the secondary data. This study also aims to calculate and interpret the measure of central tendency, variation, position of the secondary dataset. The data was gathered using a population-based data set that includes sales, income, price, competitive price, advertising, population, chef log, age, and also urban in the Malaysia. The report encompasses meticulous data collection procedure, utilization of statistics software, and theoretical model. Through measures like mean, median, and standard deviation in this report, we will learn about the data and how it was collected, how it was analyzed, and how it was interpreted using statistical software and theoretical models based on the data population.
1.0 data description, which is group data, involves explaining the process of aggregating individual observations into groups, creating a frequency distribution, and highlighting the convenience of this approach for summarizing and analyzing data. The provide dataset is representative sample of 400 distinct stores that provide information on child car seat sales, comprise income, advertising, population, price, chef log, age, and urban are the 9 variables in the dataset. Here you can see descriptive statistic, chef log, and urban. This descriptive analysis offers a comprehensive understanding of the child car seat sales dataset, highlighting key statistical measures and the distribution of categorical variables. The insight lay the foundation for further in-depth analysis and decision-making process related to sales, pricing, and marketing strategies in child car seat market.
Measures of central tendency can be divided into 3, which is mean, median, and mode. First, to find median for sales, we have to calculate all the data needed, which is class interval, frequency, and cumulative frequency. After that, we can find the median for sales by using the formula given. Hence, after calculate, about 50% of the unit sales in thousand of each location is 7.15 ringgit. Mean sales. To find mean sales, we have to use class interval, midpoint, which is X, frequency, F, and then Fx. And then we can calculate by using the formula provided. So, the mean for unit sales in thousand at each location is 7.23 ringgit. Second is mode for sales. To find mode, we just use class interval and frequency, and then just calculate by using the formulas provided. And then we got the mode for sales, which is the highest of the unit sales in thousand at each location is 6.58 ringgit. Measures of position. To find measures of unit sales in thousand at each location, we have to find quartile 1 and quartile 3. To find quartile 1 and quartile 3, we need to have class interval, frequency, and then cumulative frequency. After that, we can calculate the quartile 1 and quartile 3 by using the formula. After calculated, we found that quartile 1 is 3.4275 and quartile 3 is 9.0694, and then interquartile range is interquartile range is 5.6419. Measures of variation. Sample variance for unit cells in thousand at each location. First, we need to have class interval, midpoint, frequency, fx, x squared, and fx squared. After that, we can calculate by using the formula provided. And then we got that standard deviation is 2.010, and the shapes of data description is skew to the right.
My name is Masha Prakaita. My meeting number is 82 design of graphical representation. Graphical representation refer to the use of interactive chart to clearly display and simply dataset. So, for the first one, we use the histogram to present the start the first class with the midpoint at 25.5 where the frequency is 20, and end in the last class with midpoint is 1.5 where the frequency is 50. Let's also use histogram to present the frequencies. As you can see, the class start the first class with the midpoint at 2.5 where the frequency is 90, and end in the last class with midpoint is 1.8 where the frequency is 2. Next, we also use alternative frequency or output graph to present the edge. The cumulative frequency graph or output is a line graph that shows the cumulative frequency of each of the class or tree. So, we can see that the graph is labeled that expressive with upper boundaries and lower axis with cumulative frequency. The graph starts at 25.5 where the cumulative frequency is 0, and the graph ends at 84.5 where the cumulative frequency is 159. Last but not least, we also use a pie chart to present the shape block in urban. A pie chart is a circle diagram arranged as a pie, which basically represents a category of data that makes up the word. Together, the pie presents 100%. First, we use pie chart to present shape block. So we can see that the pie chart is labeled with 3 categories. So the highest category is medium with 58.49%. Followed by back category with 23.27%, and last one is good category with 18.24%. Next, we also use pie chart to present the highest category is yes with 68.55%, followed by no category with 51.45%.
So next, you can see 5.0 measure of center tendency. We use sales, which is standard deviation and variation shows different result because the error of system SPSS to analyze the data separately, which is the data class interval is so large. Next is measure of position. Description is standard deviation and variance show different result because the error of system SPSS to analyze the data separately, which is data class interval is too large. And then ratio of variations. Description, the result SPSS for data simple variance and standard deviation is not the same as manual because the SPSS cannot read the data accurately.
Okay, for the 4.1 hypothesis testing. Step 1 formulation of hypothesis. Null hypothesis HO. There is no significant difference between the compass touched by the competitor and the average age of the local population. Alternative hypothesis. There is a signification between compass touched by the competitor and the age of the local population. Step 2 signification level 0.05. Step 3 statistical analysis. The F statistic for the complex is 701.1863, which is statistically significant at the P more than 0.001 level. This means that there is a very low probability less than 0.001 that the observed difference in the competitor price could be due to the change alone. Number 4, decision making. We can reject the null hypothesis and infer and the price charged by the competitor different significantly from the average age of the local population, and reject H since F since 3.5 more than 700 1.816.
Based on the data provided, the value of R between sale and competitor price 0.024. R value for sale and income is negative 0.005. The value of R between sale and advertising is 0.025. R value for sale and population also is negative 0.037. The value of R between sale and price is 0.005. R value for sale and age is also 0.005. Based on the data given, the correlation reveals compelling patterns in the relationship between sale and different variables. Firstly, there exists a moderate positive linear relationship between sale and advertising with a percent correlation coefficient of 0.281. This indicates that higher advertising expenditure and associated with increased sale. A correlation statistically significant at the 0.01 level to tail. On the other hand, the correlation between sale and competitive price is positive but with a coefficient of 0.075 and it statistical significant. Furthermore, sale demonstrated a moderate positive correlation which is 0.183 with income, implying that higher income level are. Conversely, sales show a moderate negative correlation with price negative 0.403 and age negative 0.294, indicated that as prices and consumer age increase, sales tend to decrease. These negative correlation are statistically significant at the 0.01 level to tail. Notably, the correlation between sale and population as well as sale and competitive price are weak and not statistically significant. Summary: this information provides a foundation for further analysis and decision making, offering key insight into the factors influencing sale. However, it is crucial to note that correlation does not and other explored variables may contribute to the observed relationship. Based on the table, the R-square value is 0.542, which means 54.2% of the variation in sale can be explained by age, income, price, advertising, population, and also competitive price. The adjusted R-square in 52.4%. The Durbin-Watson statistic is 1.879, which is close to the ideal value of 2. In summary, the model with its substantial R-square, significant exchange, and also Durbin-Watson statistic close to 2 demonstrate a strong fit, and the inclusion of predictors significantly contribute to explaining the variance in sales.
5.4 Confidence interval. From the data provided, we can find that the mean for sales group is 7.4963, while the upper bound is 7.7739 and the lower bound is 7.2187. The difference between upper and lower is 0.5552. The mean for competitor price group is 124.0 196.98. The upper bound is 126.48 and the lower bound is 123.47. The difference between upper and lower is 3.01. The mean for income group is 68.66. The upper bound is 71.41. The lower bound is 65.91. The difference between upper and lower is 5.5. While the mean for advertising group is 6.64. The upper bound is 7.29 and the lower bound is 5.98. The difference between upper and lower is 1.31. Next is population group. The mean for population group is 264.84. The upper bound is 279.33 and the lower bound is 250.35. The difference between upper and lower is 28.98. Next, the mean for price group is 115.80. The upper bound is 118.12 and the lower bound is 130.47. The difference between upper and lower is 4.65. But not least is age group. The mean for age group is 53.32. The upper bound is 54.91 and the lower bound is 51.73. The difference between upper and lower is 3.18.
Okay, for the 4.5 prediction modeling. Dependent variable price, independent variable sale and advertising. And the formula for regression equation price for to the price modeling sale plus advertising. Okay, we can interpret that sale the project value of price when both sale and advertising are zero. Say minus 4.131 for every unit 1 in sale, price is expected to fall by 4.131. Assume the advertising remain consistent. For the advertising 0.631 for every unit increase in advertising, the price is expected to rise by 0.131. Assume sale remain consistent.
Conclusion, with the data that we obtained in our lecture, we can perform all the statistical calculation that we need for the assignment. We use INO159 sample data set. We also calculate the class interval, relative C, relativity C, relativity C, midpoint, upper boundaries, and also lowest boundary to complete the graph representation. We also describe the data set with various numerical descriptive to show operation by linear regression and the SPSS system. We found that the values are different between the manually calculated and the SSPS system. So that's all from us.